Okay, we have a couple of parts to finish out our tool post. So let's go take a look at the adjusting nut and the washer. And the washer has a slot in it, otherwise we would just go to the toolbox. So let's fly this out of the way. We got some numbers, 875. Diameter of 5/16, 3/16 thick, 16th deep, and then the slot a little over the 3/4, so it has a clearance built in. So we would want to look at its tolerancing as well, because realistically that should not be tight to the wedge. So go into the part inch. We're just going to create a donut. So might as well put it on the front plane. And we'll draw the two circles and go to 0.875. And we had 313 5/16 for the center. And we'll extrude this out to 0.188. And go ahead and accept. All right, from the sketch then looks like I'm in the center rectangle, so we'll just go ahead and leave that there. If I didn't do the center rectangle, I would just pick that line and that circle and make them tangent, but since we have the center line, I can make those coincident to the perimeter of the circle. And then we're going to go 752. So that 752, though, at this first iteration, first pass on the process, that 752 is something that I'm going to want to go back and analyze, because it may be a tighter tolerance. If we use stock material on the wedge and it's 750, I would really like to have a dimension that is like 750 minus 2,000ths, and this one would be 752 plus 2,000ths, so at most I would have 6,000ths of clearance. All right, so if we start thinking about those tolerances now, when we get to the drawing side, then we have reasonable, reasonable start on the things that we're interested in controlling. All right, I do not see a chamfer on that one, so we're going to go ahead and save this as the washer. Let's see, it put me back into level 9, so we want to make sure that we're saving this to the correct, and I will give it the prefix, the tool post washer, and save. All right, so go ahead and close that, and then we'll be on to the knurled knob. All right, so the knurled knob, did it again. There we go. Let's go ahead and zoom that up. So 5/16, 18 through. So we could do this as a revolve. We could stack two circles. Don't know, or two cylinders. Don't know that there's going to be any great advantage to one over the other. So let's go into the front plane again with the knurl. We're going to revisit that later. So if I wanted to actually 3D print one of these and have that texture in it, then we have to do something else. So the extension is 625, and the OD is, let's see, 1.062, so 1/16. And when we go to extrude this, I'm just going to use both of them for the start. We need selected contours, and see if it just let me have the outside, but no, since it's not going to let me have the outside, we'll just go ahead and pick. There it is, the contour and the region. Nope, it did pick that one up. So I do want to make sure that I'm picking both of those because I really don't want it to be a cylinder, a through hole. Yeah, it's just strange the way that it managed to select those. Alright, well, I'm still kind of seeing the geometry there, but we're going to go 313 and see what it looks like. Yeah, it sure did. Alright, well, usually it would let me, and it may be that it had those picked first, contour and contour. Okay, so it was I was getting the contours, but I don't know why it wasn't completing it. Anyway, let's go ahead and highlight sketch 1 so that we're back into that same sketch, so I can go into the extrude, and then we'll clear that. Really doesn't matter which way it goes, but we're going to go to the 0.625 and accept it. And then we want to use the hole wizard so that we get the cosmetic thread, we get all of the correct information. 5/16, 18, up to next is fine. And the position then is at the center. If I hit the checkbox, then it goes ahead and completes because I've given it everything that I need. And I've said it before, but I'll just send the reminder that I am in the ISO drafting standard, which has this, let's call it 270 degree, 280 degree cosmetic thread. The ANSI standard will have the dash dash. All right, so we need a chamfer, and they're giving that as 0.03, so a 32nd, 0.03. And we'll go ahead and save. And then this is the TP and adjusting nut. Or knob. All right, we've got all of our parts now, or at least enough of them. So let's go ahead and open up the assembly. So a new assembly, and we're in inch, pounds, and seconds. We're set to start the command when creating new assembly, so we will browse. And tool post body is a likely candidate to be our first item. Right, so again, we want to go to that OK check mark so it lines up the origin to the origin. If somehow it clicks out here and we miss, I wouldn't bother undoing it. I would just expand out and go to float. And then we would be looking at adding mates for the front to the front, top to the top, right to the right. And those would all be coincident to bring it into the exact same position. Because if we're going to do center of mass, that origin has to be in a calculable location. All right, so let's insert, make sure we're in the assembly. We'll insert components. We want the bolt. All right, and I did put a mate reference on that one. All right, so since there's a mate reference, it can go to this side, but I need to hit the tab. And it's not really reversing like I expected it to. All right, so we'll drop that in. And would think that the T slot would have a little bit more of an adjustment, but that gets us enough to get started. So selecting the two faces, and so select, control select, and then parallel. That will just set the alignment. So whatever gap we have there for the actual plate or T slot that goes in, that this goes in and rides on, we'll be able to make that adjustment. So insert component, we'll bring in the wedge and place the wedge. So that can be select, control, select coincident. All right, and the select control select is just going to be a smooth rhythm, fastest way to get this geometry in. If you prefer the paperclip, we'll bring in the paperclip. So there is a calculation that we need to do that would be kind of the furthest we'd want this out and the closest. So for our static, let's just go ahead and create a static configuration just so this doesn't move strangely when we add other things to it. So I'm going to add a distance mate, and we're close to 5/8, so 625 is good. And that will just hold it stationary, and that distance will be something that I can identify pretty easily if when I go to make this a dynamic assembly. So we need to bring in the adjusting screw. All right, and if you decided that you like one of the other processes better, so I'm kind of okay with it doing that, but I think we're getting, it's moving a little too fast. So, all right, so let's go ahead and apply it. And since, yeah, it's going to, I believe it's going to the 2026 version is going, SolidWorks is going to have more automatic mates. And so I think it's doing some of that for me. The concentric is fine, and I don't really want to lock the rotation just yet. The coincident is where I'm going to have the problem. Low on memory. Interesting. Yeah, we'll go ahead and see what it does. All right, so we can see through. Cannot find it necessarily, so I'm going to do a right click and select other, and we're going to go down through until the list until we find the mate, or to the face, and that does not look like it applied it. All right, so let's go the other route, and I am going to suppress that mate and pull it out of the way. And even in the suppression state, this is one of the features that we can select. So let's go from face to face, since I don't really think it liked the edge. And then accept it and go ahead and unsuppress it. All right, so that gets it into position. And then to check our clearances, it doesn't really matter which side we go to, but we are going to want to make that parallel because there is just a little bit, or there's supposed to be just a little bit of a gap tolerance there, 188 plus and 186 minus, that it would show up there and would not allow it to go to coincident. All right, we'll bring in the washer. So it's not really finding anything there, so I'm going to verify that those little stars, because we've seen those a couple of times, and then I'm starting to notice that it does more with the mates. So parallel, did it make that coincident? No, it did parallel, so last one will be to go to the face, and that's just going to be kind of an anti-rotation. I don't know that that's necessary, but it is going to limit how close we can get to the body. So let's insert components. I'm kind of saving the hardware for last again. So we need the adjusting nut. And I wonder if I'm low on resources. There we go. I really don't have that much open, so not sure what it's using up. All right, so to the Y, we will rotate 90. Again, if you're not finding the little context, we're going to right click and use the button, or the selection out of the right mouse button context. Let's go to concentric and coincident. Now, as far as rotation, there's nothing really here. I don't know that it matters if it rotates, but you know, for our static version, it would be nice if it it didn't do anything strange. For the dynamic, we will probably. Oh, it didn't pick one up. Okay, so I hit the wrong one then. It was not. Was not suppress, it was lock rotation. There we go. All right, talking and not paying attention to what I was doing. Let's go ahead and insert components, and we're going to find the screw on top. That one jumped right in, and let's see if it'll do it again. So since I did not apply mate, I'm thinking that that is the new assembly functionality that is being added. All right, so we get those in position. Are they where I want them? Probably not. Probably not whatever tool we're going to put in there, but let's go ahead and lock the rotation. And my goal in locking the rotation is just to, I did it again, suppress. Got suppress on the mind. Let's go ahead and lock the rotation. And the goal is just to make sure that everything is in position, that I'm not seeing anything strange in the assembly. And then when we go to make it dynamic, we have a good stable foundation to start from when we're going through this process. All right, so if you have the design library, which you should have the toolbox, we'll go ahead and add in. And since it did give me a warning about my resources, and give this a tool post assembly. All right, and then if it crashes or something, I can recover. All right, so the add-in is going to launch the toolbox, and that was actually pretty quick. I'm surprised. We do have I do have some that are on the network, stored in the cloud for the design library, and it takes a second for it to launch. So I guess the local is going a little faster. All right, so what we're looking at is the hardware library, ANSI Inch. We're looking for, actually I should look for the washer first. And let's just go with a plain washer A-type. Preferred, selected narrow. I don't know, we'll see what that looks like. All right, so as we bring it into position, and these are going to be pretty close to standard. If we went to our McMaster-Carr website, or we went to any of the supplier websites, we should be able to find something that is pretty darn close. All right, we're given the thickness of 109, outside diameter of 125, 562. That's pretty standard. So we'll go ahead and accept that. If I want to bring in more, I'm just looking for other places to put these. But since I'm done, we'll go ahead and accept. And then now we can, and I would say if you're looking for this, you know, try some of these different items, see what you don't necessarily have to pick that one, see what some of the other ones do. On the hex nuts though, there are some really big, there's the thick, the standard. Some of these don't even go to that size, they are that large. So no, I don't think I want it going that way. I don't think I want it going that way. So let's see if I can zoom up. No, it's not going to let me zoom up. All right, let's just go ahead and place it so it gets to the right size, 1/2-13. And we'll go ahead and kick that out. So it is reasonably accurate. It's not always perfect though. So since I couldn't get it to snap to the washer, I'm not going to mess with it too long. We're just going to apply the coincident. If I go back and look at these two, we'll try to lock the rotation. There we go. and lock the rotation. All right, so that gives me, oh yeah, everything except for the set screws. All right, so the set screws will kind of be an adjuster, make it repeatable. So we need to go to bolts and screws, and we are looking, let me spread that out a little bit. So let's just go set through solid, since that's what they showed us. So oval point, dog point, slotted, cone. I don't think it needs to be a cone. They're just showing it as a flat, but yeah, let's go with the flat point then. And we're going to drag and drop, and we'll put that in position. Go ahead and accept it, and put it in position. The right mouse button just goes ahead and completes it since it's the last one. Yeah, it's pretty small. So we need to edit these because they are both going to be a little bit longer, and since I didn't check it, they're actually calling this out at 1.5. These go up to 0.75. So it does depend on what we can find in our hardware. All right, so I think I'm not too worried about, from a design, if it came down to actually making a choice on what these are doing. Let's just put 30-second there, and we'll show it in the mix. All right, so that gets us to the assembly. Before we go into the drawing, we will, I think we'll go ahead and do the explode. All right, so this gets us to we've analyzed, we know what some of the issues are. Let's see if we can find our screws. See, is it going to go directly to a set screw? Yeah, there we go. Went right past it. So cut point, flat. Yeah, we tend to, on these, one of the advantages, just thinking about the hardware. So they do have a 1.5. So let's do a download. All right, and then it's set to SOLIDWORKS. If it's not set to 3D SOLIDWORKS, then you would want to. And that's going to put it into my downloads folder somewhere. So I'm just going to go over and grab it and paste it into the folder. All right, so the thing is, these are going to be hex, and one of the things with the stainless steel is they are strong, but they are also softer than the black oxided steel, and to a certain extent. So what that does, if one of these gets stripped out or broken, then we can drill it out without too much problem. So let me just take one of these. We'll make this optional just to show you the process. I've downloaded the screw. I've got it open over in my folder. There isn't really a mate reference or anything with that one. I'm going to go ahead and make it coincident and flip the mate alignment. So, the 1.5 does stick out the back quite a bit, but if it was slotted, it'd probably be good. I don't know how much, if you had a 1/2-inch tool in there that you were trying to adjust an angle or fine adjust an angle, that would be okay. So let's see if we can take that edge and make it concentric. And we'll go ahead and lock the rotation. So we can see the difference between those two. So if you want to download that, or if you need to download any of the other items, it's pretty much the same thing. We can type in the hex nuts, and we're looking for a standard hex nut, and probably would go either with a regular steel Probably don't need high strength. Might go with the stainless. You know, it's going to come down to cost at some point is what we can get. So a half 13, we would download those. And the washer, same thing. We could download those models and insert them if we didn't have access to the toolbox. All right, so the exploded view then. Let's go ahead and create our first chain. I'm just going to go ahead and grab those items. And somewhere I clicked the Y, so I got to get rid of that. All right, let's clear the selections and start over. And I'm going to stay away from that that triad. There we go. And that went out pretty far, so the auto space, I think I'm going to pull the auto space back to a little bit closer. And then we can hit the done. And then these two. So we notice that it's highlighting in blue. You just want to be careful that you're not clicking one of those to begin with. And let's see, we'll go ahead and hit the done, and we can pull that out a little ways. Oh, and actually, no, I did not want those to exist, so make sure you're hitting done in between. And if yours looks completely different, that's fine. It doesn't have to follow these steps exactly. Keep forgetting to hit done, which is pretty standard. All right, so there's my exploded view for the assembly, and we're ready to go through and make the drawing. So let's make sure we save everything, and we'll wrap this one up.